And I'll start from there, basically. I have a list of things to kind of cover as introduction, and as I go through this list, I will try to tick off items that I mentioned, just kind of basic MATLAB things again. I would also appreciate if you could, this is the first time I'm running this session online. I've done some teaching, so that seems to me is working as it is working fine for some students, okay, for some other students. Nobody had any major complaints, so I'm thinking, okay. But for MATLAB, if you, after session or during the break or something like that, if you have some suggestion on how to improve things, feel free to type that. Please mute yourself. Okay, so first item on my list says MATLAB environment. When you switch on the MATLAB, you will see, I think I'll have to mute people at least to start with, so that people who are coming a bit late are not making too much noise. So as I said, when you switch on the MATLAB, you should see some kind of environment looking like this. Maybe not all of those windows will be on, but I'll show you how to include them if you want, if I can still remember that. What do we have in MATLAB? Well, first of all, we have this top so-called ribbon here with a couple of options. There's various kind of things there, but at the moment, I'm not going to go further with that. We'll start writing some bits and bobs, and then new options will pop up, and we will maybe take it on there. The next little window here on the left-hand side at the top is current folder window. And that basically is just like any other window explorer window, just gives you a list of files that you have in your directory and that you're going to work on or add to it or something like that. One thing is important maybe to mention here, once you start writing code in MATLAB, if you don't do any other settings, your MATLAB can only see functions and other bits of code or data that's in current directory. So if you're like me and have opened a new folder and have nothing here, but referring to some of the function maybe that you written 2 weeks ago in some other directory, MATLAB will tell you there's no such function. So then there's two ways, either to move to that directory or move that function to your directory, or to set path. There is a, you see here, I hope you can see my pointer, there is a set path option here. That's, I used to do that some time ago, then I gave up. I just moved things that I want to have in my current directory, and I work with those things. If I need something, I add to it, and that's always better when you want to kind of zip everything and send it to somebody to have a look or to run it. Then you don't have to go through all those paths looking for various bits and bobs. What else? There is a workspace window. That's the one below the current folder. That kind of gives you the list or holds all your variables that are currently available for you in MATLAB. That's, if you use some other programming language before MATLAB, I mainly used C. That's like having a little, there's no such facility in C really similar to that. In Python these days you might have something similar. Once I start putting some code in, then you will see what's happening. The last bit here is a command history window, and that window is, as it says, holding the history of your previous instructions. So if you like some particular instruction, you can cycle through all the various bits. This is all stuff I've done this morning or yesterday, and pick up some particular command that you like, drag it in the command window and execute it. So those are all good, useful help windows to have. What I found most useful, if you ask me out of those three, then probably workspace would be the most useful because it gives you all the variables. History, if you're not typing in a command window but running bigger pieces of code, it's not really important. It kind of becomes a little bit obsolete, this command history window. Current folder, you can always go to Window Explorer and have a look there. Big window here is so-called, as you can see here, command window, where basically you type your commands and MATLAB responds or does not respond depending how you want it to behave. So I can go here and just so basically this setup at the moment is like using MATLAB as one big calculator. So if I want to say 3 plus 5 and press enter, MATLAB says answer is 8. One thing you should notice here is that because I didn't say A is equal to 3 plus 5 or result is equal to A plus 5, MATLAB didn't have anywhere to store this result, so it generates its own default kind of variable for result called ANS for answer, I suppose. And that's the new variable in my workspace. So if I look into workspace now, there is ANS with the value 8. You'll see this little box here in front of ANS. If you hover, just like I'm doing now, come on MATLAB, it says 1 by 1 double. So it's basically immediately, although I didn't intend to do that, it immediately treats this answer as 1 by 1 matrix. That's what I was talking in the lecture. MATLAB immediately goes to matrix data format. And it's also double. That's kind of floating point variable here, although this is integer, but that's the most favorite, MATLAB's favorite format. So this is maybe worth keeping in mind that MATLAB treats variables, likes to treat variables as matrices unless you tell it otherwise. These days when I started using MATLAB, they introduced cell type variable. That's something similar to structure in C, I suppose. So that's kind of aggregation of different data types that can hold together. So you can have array of cells. So it's almost like a matrix, but for one particular bit, you can have textual data, you can have date, you can have floating point value, all kinds of stuff. I'm not very good with cells, I must admit. So as soon as I see something as a cell, I'm thinking, how can I convert this into matrix? There's also one more useful, I noticed, variable type these days. It's called table. I think that's invented to help MATLAB interface with Excel, I would say. So table is almost like an Excel spreadsheet. And when you load data from Excel, which can be really done easily these days, table immediately strips, if there is a header, you know, like some measure instruments produce some kind of header and all kinds of rubbish previously. I had problems importing that. It's a bit fiddly importing that into MATLAB matrix because then you need to strip all those things off. If you import it as a table, MATLAB does it automatically. So then you can convert table to matrix and happy days, you can work with matrices from that point onwards. So that's all about command windows. I can now go and type whatever I want here. So probably better way to do this would be to say A is equal to, let's see what kind of operations I can do. 3 plus 5 minus 2, put all that in brackets maybe, divided with 4. What else can I do? Put all that in brackets, take square root of that, SQRT, and press enter. There comes the answer and the new variable in my workspace. Now you might think that this is really useful to have this kind of feedback from MATLAB, but imagine as we will if we work with the signal that's 120 samples long or 1120 samples long. When you do something on that signal, you filter it, all of those samples will be printed in the command window, which can be a little bit annoying and you can lose the track what you were doing. So to prevent that, sometimes you put semicolon at the end of your instruction. So let's say I want to repeat this instruction, but I don't want this result to be printed here. How can I repeat the instruction? I can go in command history and just drag this one. There it is. And let's say I also want to take the result to the power of 3 maybe. So I'll put another bracket here just to show you how to do powers. The little hat is the power, 3, semicolon, and you might ask yourself, did anything happen? But when you look at the workspace, now I have A, which is definitely different to my previous A, so I suppose this has been done correctly. So semicolon if you want to prevent printing, and without semicolon if you don't want. If you do want printing to still go. Somebody nice said you should mention that you can also press the arrow keys up and down and cycle through the history. Believe it or not, I have it in my list of things to say. So other way to do command history is to go arrow up and arrow down to cycle through the command history. So if I now press, you cannot see it, but trust me, I'm pressing arrow up, all the previous commands are popping up. Down, I'm going back in my list of commands. Okay, so I think that's the use of semicolon covered and various windows explained. Well, I also did basic operations in MATLAB. Maybe one operation to mention that will be important to us, it's e to the power of something. So students try to do this. That does not work. So the other nice thing about MATLAB, it gives you kind of message what's gone wrong. So obviously this e is not known to MATLAB. To do e to the power of e square, you use exp and then in brackets you put the power. See, if I do x to the power of 1, my e comes out. So MATLAB's got those quite a few constants built in. If I say pi, MATLAB gives you pi variable. Don't worry about only having 4 decimals. Back in the memory, there's more than that. Or you can adjust that, but I can't explain everything today. I'll leave something for you to explore. So that's all good, but that's not very advanced if we keep typing this and just using MATLAB as a glorified calculator, I suppose. So what we want to do, rather than doing this very soon, we want to kind of start writing bits of code in MATLAB, or maybe not, maybe code is a bit too much, but a couple of instructions that needs to be executed one after the other. To do that, we need another window, and another window will pop up if I go to the top left corner of my MATLAB on this ribbon and I say new script. So there comes one more window, which is my editor window. Obviously, that's where I do my editing. So let's try and do some 3 lines of code. So I will say A is equal to 2, semicolon, I don't want it printed. B is equal to 3, And now I want my C to be, I don't know, 2 times A plus B. So one way to execute this is to save this as a new file in a current folder and then run that from command line. Try that. I very rarely I do it that way, although it's good to save your work. So let's do that. So save as, I'll call it demo 1. So I have my demo here. If I go in command window and I say demo 1, it runs. How do I know it ran properly? There's no error messages here. And in my workspace, I have A, B, and C. Annoyingly, I also have this A and S, which I don't want. That's from my previous session. One more time, how to open editor. Sorry, I forgot to enable this so that messages can be seen from everybody. And to do that, I think I would have to stop the session and do some settings. Let's see. Yeah, I would have to do that. Leave it like this for the time being. How to open editor? You go to top to this ribbon, and where it says new, you select script. I think it was new script previously. Once I open script, it kind of gives you an option to open all kinds of stuff. I'm pretty limited, so I only open scripts, functions. Rarely I use live scripts, but I notice students like that. I'll explain what it is, and then if you like it, you can run with that. So go new, go script, or just go new script here, and you should get your editor window. So how the hell do I execute this if I don't want to go to command window, run it, save it, command window, run it, blah, blah, blah. The easier way for me, that's how I was taught by my PhD supervisor actually, is you go into this editor. I'm not saying this is the best way, that's just how I do it. You highlight the lines that you want to run, then staying on this highlighted area, you press the right mouse button. All kinds of options come up, but the first one is evaluate selection. So evaluate selection or F9 runs my code. The only difference is now that every instruction executed will be printed here. It doesn't really matter. I mean, I don't really go over 10, 50 lines, so that's fine. And usually you kind of write your code in bits. So once I'm happy with the first part of my code, then I just go and test the second part of my code. So I said here, maybe that's a good thing to do. Unknowingly, this variable ANS state. How can I clear that variable? I can step on that variable, press the right mouse button, and then say delete. But again, I'm not doing it like that. What I usually do at the start of every of those scripts, I say clear all. That basically clears, actually, see what happens. When I highlight that one and I execute it, all of my variables from the workspace gone. That's a useful thing to have because once you start writing the code, if you don't clear the variables, but you somehow clear them here or not clear them, but you don't generate them properly in the code, in a 54th iteration of your code, you might be under the impression that everything's working fine. Close your MATLAB, come tomorrow to demonstrate your work, and it doesn't work. Simply because some variable was left in a workspace that you used, and then you forgot to generate it. If you have clear all at the start of the code, then that's prevented. If, for instance, I develop my code, let's say I run this. everything works fine. Then somehow I kind of delete this line. Let's just comment it out. So comments are percentage signs. So if I run this code, it will still run fine. Why? Because my B is in the workspace. But I come tomorrow with this code and all of my variables cleared. When I open MATLAB and I try to run this, it says unrecognized variable B. It's okay when I have 3 lines of code to know what's gone wrong, but if you have 53, that's a bit tricky. So clear all, useful thing to have. Percentage signs give you comments. That pretty much explains the MATLAB scripts. So notice I have MATLAB scripts and MATLAB functions. I have not said anything about functions, so script would be something like main code from which I can then call functions, I suppose. Any questions?
ধানমন্ডি কোন বিয়েটার কথা বলতেছে? আই হসপিটালের যে বিয়েটার কথা বলতেছে ওইটা?
You won't be able to ask because I muted everybody, and I'm not going to unmute because some people are still talking and didn't mute their microphones. What's the next big thing in MATLAB? I mean, first good thing about MATLAB is that it can visualize your data nicely. So going to the example maybe that I've done with sampling the sine wave, I can try and plot it. Is that the best thing to say now? Yeah, maybe. So let's leave this as it is, but now I want to write another piece of code that will do something totally different. That doesn't make sense, but doesn't matter. That will plot my 10 samples of my sine wave. First of all, how to input those samples to make them behave as one consistent signal. Now I'm getting into territory of matrices, MATLAB matrices and vectors and so on. I showed that in a lecture, but I'll show it again. So I had samples, once I sampled and quantized, I had samples 4, 6, 7, 6, 4, 2, 0, 2. How do I plot them? I say this is my signal, open the square bracket, do 4, 6, 7, 6, 4, 2, 0, 2. Close the bracket. Now this bracket basically, just as in maths, indicates the start and the beginning of my matrix. In this case, my matrix is going to be just one dimensional almost. It's going to have one row and 1, 2, 3, 4, 5, 6, 7, 8 columns. I don't want it to be printed on the screen, so I put semicolon here, but I'm going to execute it. It's okay. There's my X and there are my variables. If I hover over X, it says 1 times 8. So 1 is the number of rows, 8 is the number of columns. I should probably say more about vectors, but let's leave it for the next item. How do I plot this? I can basically say just plot X. Let's execute that. Now comes the problem, because you can probably not see the picture on your screens because, how shall I say, my picture window is undocked from the main window. So I think WebEx only takes one window that I indicated. So what I'm going to try and do, which is going to make it a little bit more complicated, I will dock my figure window. Do you see it now? You can see it regardless. Oh, that's even better. Can I undock it? Oh, that's good, because I thought that's not possible. So if I go to this little, see how to undock. Go here and say undock, and there's my picture here. So that's excellent news. Previously it didn't work like that. Ah. So I grab my figure, and that's pretty much my sine wave. Not much of the sine wave. Maybe, what can I do about this? Well, I want to see the samples. I don't want just those lines. I want to see my samples. How do I do that? I think I showed that as well. You're currently sharing your screen. Yeah, I suppose you're right. Why didn't it show previously when I was testing it? That's okay, even better. So how do I show my samples? I can say, as I said, plot X, but plot little circles. So when I do that, this is annoying that I now need to look for this window behind. There it is. So what I tend to do, another thing I tend to do is I always delete my figure, and then when I say plot, it pops up again. You'll see what the effect is. So let's get rid of this. What the heck? And here I say close all. So this is clearing all variables, clear all variables from the workspace. And this here is close all figures. Yeah. So if I run it like this, then MATLAB clears all the data, but it also closes all the figures. So when I say plot, my new figure will pop up and we will be able to see it. I don't have to look at it behind my main window. There it is. If I go here, picture goes in behind, but I want to run it again. Let's say I want it in red now, so I put R here. There it pops up. Yeah. How do I go about saving my points, but also connecting them with lines? It's just a trick of learning what to do under those quotation marks. So if I put little minus, it will now plot and connect. There it goes. Beautiful, I would say. What else is important about plotting? There's one more useful plot type for DSP. That's maybe you haven't seen that. So if instead of, let's comment plot, so I can comment it like this, and if I say here stem X, somebody's still making this, and run all this, then this is what happens. So all my points are on little stems. Sometimes it's useful, really useful actually. You might think Branislav's talking rubbish here, but those stems can be sometimes useful when you're sampling the signal and when you want to see the exact samples at exact times if you have a little bit more points. But then again, some students get hooked up on this stem, and if they have 100 and something points, they're still stemming, but then it's just one big mess. So if I have small number of points, stem is good. For larger number of points, not so useful, I would say. I can, of course, if I have this, some basic kind of editing of the figure, I can add axis names and everything. So I can say X label let's call it sample NO. So thing in the quotation marks will go on the X label. Y label, which I call amplitude. Let's run this. There it is, sample number, amplitude. One thing that I usually do, I don't know why, I put grid on. That kind of makes it a little bit more professional. It kind of plots a little grid behind your points so that you know where you are. Okay, one thing that's a bit annoying is, can I show that now? Yeah, why not? What the hell? So this is one, you can do font size too. Yeah, I can do font size, I can do font type, I can do all kinds of stuff. Excellent. I can see I'm working with professionals here. You can do title. Sometimes title is okay. So one good thing about MATLAB is easy plotting facility. Let's do something else. I will do double percentage sign at start here, and I will do double percentage sign here. So you can see some weird things happening. If I'm here, this gets highlighted. Those little things in MATLAB are called cells or selections, I suppose. So this is one bit of code related to something else. This is going to be another bit of code related to something else. So the advantage is that you can execute all this by just pressing run section. So if I'm here and I say run section, it kind of clears all my variables, closes all my figures. If I'm here and I say run section, kind of plots the stuff for me. If I'm here and I run section, nothing happens yet, but this is, so I'll say here basic plots or something like that. And next big thing is column operator. This is good in MATLAB. I can easily generate, so one thing that annoys me in this picture is that my samples are starting from 1. And I like them, being a proper DSP guy, I like them to start from 0. Because most of the books and everything, all those sums and everything starting from 0. How can I do that? Well, that's a bit tricky to start with. I need to generate another array from 0 to 7 that will then be plotted against this array. So I can say something like n, let's do that first, is 0, 1, 2, 3, 4, 5, 6, 7. So those are my indices. And then in stem, I can say, well, I want to plot my x against my n. Not just, if I just say stem x, it plots it against 1, 2, 3, 4, 5. No, I want this to be plotted from 0 to 7. So if I do it like this now, that's better. So now I have my first sample being with index 0, second with index 1, 2, 3, and so on. Hold command. Aaron, thanks a lot. I'll mention that a little bit later. But this leads to kind of problem. I don't want to keep generating those n's manually like this. If I have more indices and that kind of stuff, I want to be able to do it all at once. And I can do that with column operator. So if I say, let's say I want my index to start from 10 and finish at 17. I can say n is equal 10 column 17. Look what this is going to do. Let's do it without my semicolon. So I do this. N is now overwritten from here, and it's 10, 11, 12, 13, 14, 15, 16, 17. So if I now do this stemming business, I put it here, and I do those two together. We don't even have to do it. And I look for my picture. My index starts from 10. So this might look like, okay, fine, that's not too bad, but this is more powerful than just generating those integers. I can generate an array of any kind of resolution I want. So let's say I want to plot my signal against sampling times. Remember what sampling times were? Oh, I have it somewhere. I suppose I can switch on camera, but you'll have to trust me or look into your old notes. So my sampling times were 0, 0.0625, 0.125, 0.1875. Again, I would need to type that in. I don't want to be doing that. So what I can do, this is how I would do it. I'd say T, capital TS, is my sampling interval, and sampling interval is 0.0625 milliseconds. So 0.0625 milliseconds. So I'd say this is sampling interval. I say n goes from 0 to 7. So I do this kind of stuff. And then I say my times are n ts. If I do this, suddenly my 0, 1, 2, 3, 4, 5, 6, 7 will be multiplied with ts, and I get a nice array of proper sampling times. So now if I say here stem t against x, there's my sine wave sampled, plotted against sampling times. I can do that even in a bit fancier way than this. How can I do it? Let me jog my memory. So I can say, if I drop this, I can say t goes from 0 with a step ts up to 8 times ts. Let's run it, then we'll think about consequences. So again, if you look at this, I get same sampling times. But what does this line tell me? It basically tells MATLAB generate an array called t, which will go from 0 to 8 times this ts, whatever that number is, with a step ts. So don't use step of 1. I don't want that. I want step of ts. And that generates my times again. So this is much more powerful than just generating 1, 2, 3, 4, 5, 6, 7. But even that's better than having to go in C, for instance, and having a loop or something like that to do it while loop. While we're at it, if I can still remember, you can do it in a reverse direction, I believe. So I can say, I can say generate T1, which will go from 10 TS with a step of minus TS down to 0. Let's see if that works. Yes. So I started from 062505. So depending on your step, you can do all kinds of weird things, basically. Okay, that explains my column operator to a certain extent. Maybe not fully. Why not fully? Well, let's have another look at this X. So I'll jump to my X command window and just say, what is X? I forgot. It's this array here. So let's say I want to go into array and grab all those samples from 0, 1, 2, 3, and 4. I want to extract just a bit of my signal. That's when the column operator kind of is useful again. So I can say X extracted is equal X, but only go from 1 to index 3, 4, 5 to 5. That gives me part of my array, 764. What about if I want to pick up every other sample? That's too complicated. I don't know how to do that. I suppose you have to. We'll leave that for a bit later. How about now? Just to show that. So I have now, if you look into my workspace, so in which case we need to use a semicolon at the end of function. Well, at the end of call, if you don't want things to be printed. So if I did say this, but I put semicolon, nothing will be printed. But I didn't put semicolon here because I wanted to see result, so it stayed like this. One last thing about this arrays. So look here, I have now X and I have X extracted. What if I want to bolt this X extracted at the end of my X? How would I do that? I can say X new is equal, open square brackets.
ঠিক আছে ভাই বুঝছি থাকেন তাহলে
X space X extracted, close it. So this is like joining two arrays. There it is. This is my original array up to here, and then I added 764. I suppose that's enough for talking about arrays. No, not remotely enough. We'll go a little bit further with that. Couple of useful arrays here just to mention. We were talking about impulse signal. How can I quickly generate impulse signal? That's one of the tasks in one of the lab 2 list. Generate impulse and take Fourier transform of impulse. We're not going to take Fourier transform just yet, but I want to generate impulse. So impulse is going to be, remember, 1 followed by as many zeros as I want. So let's say I want 10 samples long impulse. I want something like this. Let's put another double percentage sign. And I say I want X is equal 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. Enough. Run that. There's my impulse generated, but I want to be sure, so I'll say plot X is going to be weird plot. Does make sense. There is one here, but then because it's connected, it goes to 2. So you can see I would prefer stem here, just the way I'm plotting it in my lecture. Oh, come on. So maybe you won't see anything here, but here is one little stem with circle at the top. That's the impulse, and then followed by loads of zeros. But what if I tell you I want, for some weird reason, I want 100 samples long impulse? Then you don't want to go and type 99 of those zeros. MATLAB thought of that. You can generate quickly big array of zeros. So you can say X is equal to zeros, 1 row and 100 columns. And do I want to comment it or not? No, I'm not going to comment it, just to see the mass that comes in my command window. So if I do this, loads of zeros pop up. This is when I want my semicolon to prevent this rubbish from being printed. But that's not enough. Those are all zeros. I want impulse at the start. Or let's say I want impulse shifted 2 samples to the right. How would you do that? Well, I need to access that element of X array, set it to 1. So I can go and say X of, not of 1, not of 2, but of 3 is equal to 1. So I'm going to generate 100 zeros, then the third of those zeros I'm going to convert to 1. That's going to be my impulse, and I'm going to stem it. See, this is annoying, so I'll put here at the start of this section, I'll say close all and run this section. There it is. So 2 samples 0, then my impulse, then everything else 0. Another useful command is once. Does exactly the same thing. So if I say X is equal to once, 1 over 100, that's going to generate 100 ones. But I don't want, let's say I want that step signal, and step starts at the sample 50. How would I do that? I can generate loads of ones, and then I can say X of index 1 to index 50 is equal to 0. So this is going to set all the indexes from 1, all the samples from 1 to 50 to 0. Plot this now, skip this XD. Better comment this one out and run everything. There's my step signal. Okay, that's good. I covered quite a few bits here. So how would I now, having all this accumulated huge MATLAB knowledge, how would I generate my sine wave, sampled sine wave, but rather than having 8 samples, I want 20 samples sine wave. And I don't want to keep typing those samples, blah, 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 on forever. I want them to be generated from my formula. So let's put another cell here and say sampled sine wave. Ooh, I'm running over. Maybe we'll do a little break, then I'll show how to sample the sine wave here. So just have a break, and I'll continue in 10 minutes time maybe. So it's 5 to 4, 5 past 4 we are back. I will stop what I'm, can I stop what I'm doing? Is it going to come? No, we'll leave it as this. So I'll just pause the recording and we'll reconvene in 10 minutes time. If you have any suggestions or any questions, anything, type now, and I'll try to answer. I'll try to adjust my teaching in the second hour. So I think I'm going a bit slower. I was planning to just do all this stuff and then leave you second hour to do examples. But I think it's better if I keep talking for a bit longer, then you can do examples in your own time or whenever. Okay, recording. So sampled sine wave, what do we need? We basically want to, I'll start from the equation, then we will see what's missing, and then we will fill the gaps, as they say. So first of all, say close all. I'll even say clear all. There's one more useful one while I'm at it that I usually use, like 3 commands that don't do anything but are useful. CLC. That one clears my command window. So command window becomes a bit too annoying when it starts filling with all kinds of stuff. So if I do those 3, all my variables cleaned, my command window cleaned, my picture's gone. So I want to implement basically something like this. X is equal, let's give it even the amplitude, A times sine of 2 times pi times f times n times ts plus some phase. Obviously, if I run this, there's no variables, my MATLAB will get stuck at A immediately. So above this, I'm going to start putting whatever is not in here, I'm going to add it. So A is equal to, we say 1, we'll stick with 1 for the time being. Notice this little wiggly line that appears below equal. If I hover around it, it will warn me. Terminate statement with semicolon to suppress output. So if you don't put semicolon here, MATLAB thinks that maybe you forgot it and you might get loads of output, so it kind of warns you. When I put semicolon, that disappears. Sine is built-in MATLAB function defined. 2 constant defined. Pi, I showed it already, is defined. F is my frequency, which is not defined. Let's do the same sine wave just for fun. 2 kilohertz, yes. So I'll say my F is 2000 hertz. That's my frequency. So I'll put amplitude here. I'll put frequency here. What else do I need? I need N. We said to start with we want 10 samples. So now I use my powerful column or 0 to 9. That's going to generate the whole array N, so I don't have to think about how I'm going to generate a bunch of numbers. TS, just for fun, don't put it in, but we will say Fs is whatever my sampling frequency was specified here, 16 kilohertz. So Fs is 16 kilohertz. I put here sampling frequency. Fine. So then I need to calculate Ts, which is 1 over Fs. Sampling period. If I run this, I forgot the phase. Let's just see what happens if I run this. MATLAB should throw an error saying unrecognized function pH. function or variable. Doesn't have a clue whether I want it to call function or just want it variable. It is my variable, and let's put it to 0, just to kind of start with that. So now I should run it, and there should be no complaints from MATLAB because I have this CLC. Even this annoying error message will be disappearing. So I know everything's run fine because I have all my variables here, but I want to plot it. So here I will say, well, I can actually pick up plotting bit from here maybe. Or I'll do this. I don't want to use stem, I'll use this plot. And I'll also put here title sampled sine wave. That's how you add title to your plot. Do this. There comes my beautiful sine wave. I'm not happy with my phase, so I want to put phase to what do I want to put my phase to pi/4. So notice I need to specify phase in radians simply because all this is really in radians, 2 pi. So there's 2 pi, so this is in radians. And sine function actually works on radians, so be aware of that. So if I just go and say run this section, trans gives me a little title, changes the phase, everything works fine. What else did I want to kind of add here? Yes, Aaron said hold facility. When do I want to hold my picture? Well, if I want to generate another signal, let's say I want a cosine here as well. So y is going to be all this, but instead of sine, I want cosine. And if I plot it like this, you will see what the problem is when I run it. It only plots the sine while I want it. So let's say I want to plot both of them. So I plot x, and then I say do all this, but in blue color, so say B here, plot y. Thinking I'll see 2 waves now. But no, I'm going to see just one. And it's going to be the cosine wave. That's because after plotting sine, MATLAB wipes it off and plots cosine. Every time we add new plot, MATLAB wipes the figure and puts something else. That's sometimes fine, but sometimes it's not okay. I want to see both of them on, so I then want to so-called hold my previous plot. I can do that if after this I say hold on. So then basically keep x, keep my red sine wave, and add blue cosine wave. So pretty useful thing to do. Run section. There it is, both of them fine. Alternatively, you can do something, maybe I'm going into many details, but doesn't matter. You can do something called subplot. So if I do want both pictures, but I don't want them on the same plot, but I do want them kind of in the same figure window, I can do something like that. I can do, I forgot how to do it, to be honest. I forgot how to do it. That's the reason to show you one more useful facility MATLAB has. That's a help facility. So I know that it's subplot, but I forgot how to use that subplot. So I can say help subplot here. And MATLAB thinks a little bit about that and then gives me all kinds of useful information. So it says basically subplot function is if you want more plots on one figure, M and P, 3 arguments come to this, but basically it will give you a window with M rows, N columns, and it will plot picture number, so on. So if I say here subplot 1 row, 2 columns, first picture, plot my little sign, and then forget about hold on, but I'll say here subplot same stuff, but do the second picture as the cosine way. Let's just try that. I'm not 100% I've done it right. No complaints, that's a good sign. There it is. So can you see subplot with 1 row, 2 columns. That's this subplot 1, 2. First picture on that subplot is going to be sine wave. Second picture is going to be my cosine wave. Okay, fine. So just to kind of recap, important and useful things that I like about MATLAB. The first thing is easy visualization of things. When you're working in DSP, it's always enormously useful to quickly be able to plot either your signals or your images or whatever else, and then think what to do with that, or some kind of intermediate results, or even some kind of final results. So plotting, visualization. The other thing is this powerful column command that saves me from running those annoying for loops and things to generate loads of numbers. And in fact, there is a for loop in MATLAB, but try to avoid it whenever you can. That just takes more time than this. MATLAB is written so that this basically gets executed blindingly fast. If I do the for loop to generate n from 0 to 9, that would work fine. But if I want to generate 5,000 samples, doing it this way would be quick. Doing it for loop, that'll take a bit of time. Why did you add 1, 2, 1 and 1, 2, 2 in front of subplot? Well, I'm just saying subplot, generate the subplot with 1 row, 2 columns, and whatever comes next, my plot will go in picture 1. That's the same subplot, 1 row, 2 columns, but this goes in picture 2. That's what it is. So the second thing is the column operator. And the third thing, if I'm to rank MATLAB things I like, it's between working with complex numbers, because that's really useful for installation failed. I'm not interested in that. I'm interested in that. So it's between complex numbers and functions. Maybe I have enough time to cover both. Functions are just like functions in any other language. If you go to some older languages, they call them subroutines. I think you're about to rest that computer. No, don't do that. Snooze. I don't know. I think IT is sending something that they definitely want me to install on a computer. I'll leave it for later. And snooze and remind me again in 4 hours. Okay. So functions are useful. Should I do function or should I do complex number? Let's do functions. So demonstration of function in MATLAB. Let's say I have, this is what I want to do on loads of my numbers. I have A as being 3, B as being 5, and I want to do A times A, or A squared, plus B times B. This should work okay. Look at this. If I put semicolon, but I still want my result printed, but I can't be bothered to delete semicolon, I highlight everything up to semicolon. This is my way of executing, so I kind of perfected it, I suppose. If I do that, because MATLAB does not see semicolons not highlighted, it gives me the result. And now I want to do and change A, go and change A to 4 and run it again and see what's happening. I mean, this is pointless, but doesn't matter. 41. Now I'm saying I want to run this hundreds of times in various codes, in various programs. This is really useful operation for me. It would be better if I package it in a way that I can just call this function in some way and it gets always executed. I don't have to code it, hard code it like this. Obviously, this is easy, but if I have to do 20 little things on my A's and B's, then it will be pain. I can do all this in a function. So how to write the function? Previously, I always struggled. I forgot how to write function kind of header in MATLAB and everything, but now some questions here. None of my code will run after running a script I had run before. Don't know answer to that. I would have to see the script, I'm afraid. What are you doing in the script? Leave it on the side. Let's look at the function first, sorry. So now you can just go in new, select function, and the function template comes up. Important things. Function code needs to start with this keyword function. You see it's blue, so it's almost like a kind of MATLAB, one of MATLAB reserved words, I suppose. Then comes a square bracket, which are my outputs. If I have more than one or just one, I can replace that if I just have one output. Then comes equal, then comes untitled, which should obviously be replaced. So I will replace it and call this my function. And then comes the list of input arguments. I'll say, just call this arg1, and I'll call this arg2. Forget about those messages for later. This is comment. I'll still say my function. And I'll say here, does something pointless. I'll even delete the second name. So I'll say here, so I say I want my function to have just one output, which is this C. So I'll delete one of those outputs. Just leave output argument, or I can just call it output. Output is a bit too general. Output A. And then here I'll say output A is going to be arg1, which is my input argument, times arg1 plus arg2 times arg2. This is that simple function. So when I call my function and I put A and B here, it's going to do A times A plus B times B. And it's going to store it in here and then chuck it out. Now comes the important bit, saving the function. So obviously I want to save it in the current folder. That's not a problem because I am in that folder. So MATLAB will offer to save it in the current folder. How did you generate function template? You go to new, but don't press on this little arrow, and then you get your function template. Select function. So don't go for script, don't go for live script, go for third option, function. So I want to save it in a current folder, and I want to save it with the same name as the function actually holds in a script. Otherwise, it will cause confusion. So don't try to be clever and call function my function, but then save it as myf.m or something like that. You have to save it as my function. So I'll go to save, save as, and you see MATLAB's now clever enough to offer you my function. It sees what's the name of the function and don't change it. Some students still change it. I don't know what's the reason. Keep the name as you gave it in the function. And you can see that function came and the icon is slightly different to script, just to distinguish between script and function. But now I can go to back to my demo, and I can say my D is going to be my function of 2 and 10. So it should do 2 squared plus 10 squared, 104 if I can still calculate. There it is, 104. I can put semicolon and just run it like that. Same, D is 104. Or I can say, okay, check for my A and B defined up there. I'll show my function in a second. So I can now kind of run it with A and B. They don't have to be fixed numbers, but some variables defined further up, as long as they are defined. There it is. Now D is 41, as same as my C. Here's my function again. So this might look a bit like a pointless kind of, you might not appreciate the full strength of this, but very first task in the lab that's going to be marked is going to be write your own function to implement discrete Fourier transform. And then for the rest of that script, just do all the analysis and everything with your own function rather than MATLAB's built-in fast Fourier transform function, just to kind of get into habit writing functions and checking whether you understand DFT and all that stuff. So function is kind of important, not to mention that you can do all kinds of complicated things. One thing I noticed students do, and that's they try to do everything in function. So they try to define their variables, they try to plot sine waves and cosine waves and everything. You can do that, but that's not the best approach. That's not the best function philosophy. Function, especially in DSP, is the number crunching tool. So I would say define all your variables in the script, then call your function to crunch those variables and produce the results, then pass the results back to script and plot everything from the script. Don't try to plot results in function. Then if something does not work, I'm not really sure anymore whether my function is not working. If I want to change the type of the plot and everything, you will see it becomes a mess at some point. So better to kind of leave the function just to do like something like FFT. That's a good function. Digital filtering, that's another good function. What else? Well, you will see when you get to writing functions, there's all kinds of, when you have to repeat some kind of little number, solving quadratic or cubic equation, that's a good function as well. Not to mention that MATLAB's got that already, but we're not interested in ready-made functions. Okay, That's a function demo. I would now, if I was in a lecture, I would say, are you impressed with MATLAB? But I'm not, so it doesn't matter. Last bit that I want to say, I think this is kind of last bit. There are other bits, but that's maybe you had enough by now. So the only bit I want to say is complex numbers in MATLAB. So this is big help because you can work with complex numbers in MATLAB straight away. How would you do it in C? You would need, if you want array of complex numbers, you would need to reserve one array for real part, the other array for imaginary part, then kind of define complex multiplication. You will need to multiply real with real with imaginary to get the things out. Before the MATLAB, can we have exercises to practice creating functions? Yeah. Well, the very first task in the handout that I gave is to write the function. So rather than doing sine wave as I did it like this, write a function to generate your sine. Obviously, I tried to add a little bit of complexity. You will see what's it all about, but have a go at that later. Okay, but in MATLAB, as I said, scrap all that. I can do everything on complex numbers you can think of straight away without any additional functions or definitions or anything providing. I know how to input MATLAB numbers, MATLAB complex numbers. So let's say I want number 5 real part and 3 imaginary part. And I'll call that number A. Or call it Z, because Z in the end will be after Z transform, we will get complex numbers out, so maybe not a bad idea to keep that in mind. So I want 5 real number, and I want 3 complex imaginary part. I do that by saying this is going to be J times 3. No, not semicolon. Do this, and you see MATLAB is fine with that, but annoyingly he doesn't like your J, he likes I for some reason. And even if you look into this command, you will see 2 little squiggly lines. They are not red, so it's not an error, but it's a warning. The first squiggly line says terminate with semicolon. Okay, I'll terminate with semicolon. That one disappears. But then the other one says, for improved robustness, consider replacing I and J by one I. So I can go here and I can say I, but MATLAB still complains. For some reason, they like one I. So all that works. J, I, one I, but for some reason, MATLAB likes one I. So I do that. I don't highlight semicolon, and I get my number here. Let's say the second number I want, Z2, is maybe -3 real part and -2 imaginary part. Now I know better, so I'll say 1i times, what did I say, -2. Okay, and I want my result Z to be Z1 plus Z2. If I was to do that in C, I would need to say, okay, if I'm adding 2 numbers, then I need to go into real parts, add real parts, go to imaginary parts, add imaginary parts, then consider this with I. Here, I just do it as a normal addition. And the result comes out. So 5 minus 3, 2, 3 minus 2, 1. Fine. That's not too bad, but when it comes to dividing numbers, so I can say Z is equal to Z1. How is he going to restart? Snooze. I want to restart yet. Divide those 2 numbers. Well, that's a tricky operation. MATLAB does it without any complaints. and the numbers come out. What you might want is magnitude of your complex number and phase of your complex number. That's easily done. So I can say, okay, if this is my result, take the magnitude, that's pretty much absolute of Z. Done. How do you phase? I think it's angle Z. Okay. But if I look into this Z again, that's my number. Sometimes I want to get to the real part and get to the imaginary part. I can say real of Z. There's the real part of my Z. Now, is it imag or imaginary? Imag of Z comes my imaginary part. The angle is in radians. Yes. What else is important? Now we come to important part, really. And that's the bit, is it too much or can I just do that bit? Euler's equation. Well, Euler's equation is important, so I'll spark my camera again. That's really the last bit that I'm going to do today. So the idea is if I cover all this today, then next week there's not much for me to talk about, but you just work on that handout. I will be online, so probably I don't know how to do it best to give you some help. I will open the chat box and I will do nothing on the screen. So I will just sit back and relax. And if you work on this lab sheet and you can post the problematic code that doesn't work or something like that in the chat, I will copy it, paste it into the MATLAB, and I will show you how to sort it out. Where can I get the video recording? Well, the video recording is going to come up on DSP Moodle site. If you are not listening to DSP, but Power System students which are invited or somebody else, then I will then send me your student number via email, not now because I don't have time now, and I will try to get it to you somehow. Okay, the last important bit. Euler's equation. We're going to use it a lot, right? And it's to do with complex numbers. So I'll try to explain it and demonstrate it in MATLAB. Basically, Euler says that if I have my constant E to some power, let's call it x, and I make it complex power, so jx, then this is going to be cos x plus j sine x. Pretty impressive relationship. You must have mentioned it in your first year or second year maths, I don't know. But basically it is important because it says if I have a cosine for DSP people, if I have a cosine periodic wave and I have sine periodic wave, I want to manipulate and test various systems or signals, I can nicely condense them like this. So all should work fine. Let's just demonstrate that in MATLAB now. So How to do it? I'm going to maybe use, should I do it? I'm going to use all those angles here. So in reality, when generating sine wave, this is just one set of angles because n is changing. So I will say my angles, call it alpha. No. Let's do it like this. I will say E, remember E to the power of something looks like this. And if I make this, complex, so I'll put one I, as MATLAB wants me to put one I, not I or something. So what do I have here? Here I have E to the power of j 2 pi f n t s. Yes? Just to make sure that everything is fine, I will copy all this. Into my current cell. And I will call this signal X. So what am I trying to do here? What am I talking about? Well, those are my angles, and I'm making them complex now. So this is really first part of Euler's equation, e to the power of j 2 pi f n t s. It should execute okay. Yes, but if I look into my x, I can see that those are kind of complex numbers. So if I pick up now